Hi everyone, and welcome back to the lecture on mastering multivariate analysis. In this particular lecture, we're going to dive deep, particularly into these things, and we're going to discover patterns and insights. And we're going to discover that specifically by utilizing a method called EDA, which is exploratory data analysis. So with that said, let's dive into the lecture overview. First of all, we're going to go into the importance of EDA, the steps in EDA, the techniques and tools of EDA, practical examples, and then we'll go on from there. So as far as the importance of EDA, definition. Exploratory data analysis is an approach to analyzing data sets to summarize their main characteristics, often utilizing visual methods. That's the end goal, right? Is how do we actually visualize these concepts? And to give you kind of an overview of why we do this, the goal is and the intention is that visualizing a data set and visualizing the concept and an outcome can have drastically different differences and outcomes. You know, if I tell you like 1 in 10 dentists agree on something, or if I make a commercial and I show like 1 in 10 dentists, there's a big difference there, right? And it's that visualization. How exactly do you visualize that 1 in 10 dentists? And that's what matters. And then so the objectives within that are to identify the patterns and anomalies, check assumptions, determine the relationships between the variables, and then inform further statistical analysis. So you always want to follow this pattern in this process. And then so diving deeper within that, EDA is all about pattern and process. It's not about just let's go loose and do whatever we want with our data, right? So what are the steps within EDA? The first step within EDA is to understand our data. Then we want to clean our data. Then we want to summarize the data. And then lastly, we want to identify patterns and relationships that emerge from that summarization. So understanding the data involves our structure and our data types, as well as our measurement scales. How exactly are we going to, what does our data set look like, and how are we going to measure it? Cleaning the data, there's two things that you can do. You can handle missing variables, and you can correct errors. So you can remove data and add data, plus or minus. That's basically it, right? Summarize data, you can utilize descriptive statistics and visualizations. With regards towards identifying patterns and relationships, we can utilize correlation analysis and multivariate plots. And then within that, we can utilize several different methods. As far as data cleaning techniques, so let's take this a step further and look at each of these individual steps. For data cleaning techniques, we can handle missing values and we can correct errors, again, plus or minus. So with regards towards that plus, we can do imputation or deletion. So we can clean or remove, again, plus or minus, always plus or minus, right? And then with correct errors, we can do outlier detection and handling and or consistency checks. So we can check across the board that everything is good and do a broad scale, and we can do that on an individual scale. So big, small, plus, minus. Really simple, right? Kind of how it breaks down to me. With regards towards our descriptive statistics and our summarization, essentially the tools that we're going to be utilizing within this, right? So up front, the big thing is just knowing and explaining the tools and being consistent with your tool use across your experiment. That's what really matters, right? It doesn't matter to me necessarily which central tendency that you utilize, meaning mean, median, or mode. And it doesn't matter necessarily which dispersion that you utilize, variance, standard deviation, or range. Those matter a little bit more than mean, median, or mode, but you have some variance there, right? And then same thing with multivariate descriptive statistics. You have mean vectors and covariance matrix, and these are just how you graph out and how you visualize this, how you get to the end result. In each one of these steps, there's a choice that you can make. You have choices as to how you can break down, how you can analyze, and how you can visualize this data. There's two types of lies in the world, right? Statistics and damn lies. And within statistics, you can mold and shape and change the data. And then how you do that is important. And it's very important to document that. And then so that's this step where this comes in, this descriptive statistics and summarization, summarizing what you're doing and what your actual method is. And then as far as visualization techniques, breaking it down, this is again like another method where you can change the outcome of the data partially or in full, right? And then there's very different ways, like how you visualize the data is going to be like the most important aspect at the end of the day. For the non-technical person, for the average person that's looking at your data set, the visualization is not going to be what they're going to get past. So within that, you have essentially three different methods that you can use. So univariate, bivariate, and multivariate, just depending on the types of data set that you're trying. Are you trying to visualize like one variable, two variables, or multiple variables? And then within that, you have methods of visualization that you can do within that. And then so the goal would be, I would break this down to you, is to explore different visualization methods, explore how your data visualizes across different methods, and then see what that looks like, and present the best result at the end of the day with regards towards visualization. Then that leads us into correlation analysis. The definition of correlation analysis, very specifically, is a measure of the strength and direction of the linear relationship between two variables. So remember, the relationship between two variables is always going to be determinant based off of strength and direction. So like, how strong is the relationship, and then is this the relationship towards each other or against each other? Like, are they polarizing or coming together? And then as far as techniques, you have essentially Pearson correlation and Spearman rank correlation. And then so these are just two measures of strength and direction. And then with your correlation, you have correlation matrices and heat maps, which again measure the strength and the direction of the relationship. So it's all measuring the relationship between variables and trying to determine kind of what exactly the relationship is, and how strong that relationship is, and what direction the relationship is. It doesn't get much more complex than that. At the end of the day, there's not a lot more that you can do with the data at the end of the day. So that leads us to the conclusion and our next steps. So as far as the importance of EDA, I hope that the big thing that you've gotten is that that EDA gives you a methodology and a framework to follow with when you go within this, right? So at the end of the day, what we're talking about is data exploration, and you should not be afraid to explore your data in any way that you like. But the goal is to give you a framework and a method for moving forward within that. We also went over the steps as well as techniques. In the next lecture, we'll be going over predictive modeling and diving more hands-on onto these things. So I look forward to seeing you in the next lecture. Thank you very much.